So now that you've had a chance to get a glimpse of some of the streams operations, things like the factory methods, the common methods for creating a stream, some of the common aggregate operations, we're going to turn our attention to visualizing how Java streams work in action. And the purpose of this is to give you another perspective on how all this software works under the hood. So the key thing to remember about a stream is it helps to enhance flexibility by forming a processing pipeline that can be used to compose multiple aggregate operations together. So when you have something that needs to be done in a series of transformations or filtering operations and so on, the stream may be the right choice. So you can think of it as basically a little pipeline where things start at the beginning for the factory methods, and they flow all the way through to the end, which are the terminal operations we've talked about. You can think of this very similarly to the types of filters you might have if you have a water filtration system at your house or someplace you go, where the water flows in and it's filtered to remove impurities. In this case, we're not really removing impurities per se. We're performing the transformations that are important for our processing operations. So this is a visualization of a stream that we're going to use as a simple example to walk through and kind of help you see literally the bigger picture of how the pieces fit together. So you can get this example here in my EX12 folder in my GitHub repository. So on the left-hand side, we're going to have kind of the visualization. On the right-hand side of the slide, facing the slide, we're going to show snippets of the code that you would write. So this is all going to start out at first by taking an array of names, which is the list of characters from Shakespeare's famous play Hamlet. And that's going to start out as an array of strings. And we're going to use the of operator, which is a factory method, to convert that into a stream of names. So you can see here we have a stream of names on the right, and then the left-hand visualization kind of shows you what that stream looks like. So Horatio, Laertes, and Hamlet are now extracted or converted from being an array of strings into a stream of strings. And obviously under the hood, that's a data structure of some kind. The next thing we're going to do is we're going to apply a filter operation. This is an intermediate operation that takes the input stream and gets rid of anything that doesn't start with an uppercase or lowercase h. So we end up with a stream of names that start with upper or lowercase h. So we end up with Horatio and Hamlet. Poor Laertes gets left once again. And then we're going to go ahead and apply another intermediate operation. This is a map operation. So this is going to apply this transformation, which is the method reference capitalize, to every element that's left in the stream. And after we do that, we're going to have a stream of canonically capitalized names where the first character is capitalized and the rest of them are lowercase. So now we have Horatio and Hamlet properly capitalized. And then the next thing we're going to do in the stream is we're going to go ahead and sort it. Now remember that things like filter and things like map, those intermediate operations are so-called stateless operations. And that means they don't require any knowledge of things that came before or after in order to do their job. In contrast, sorted is a so-called stateful operation. No surprise, you've got to collect up all the various elements in the stream before you can sort it. Wouldn't make any sense to sort just a handful of the elements. You wouldn't end up with a sorted stream when you're done with it. So we have sorted, and the outcome of sorted is a stream of sorted names. So now good old Hamlet comes first, followed by Horatio. And I've left off the terminal operation here, which could be whatever it is. It could be a for each terminal operation. It could be a collect operation, and so on. We'll look at those a little bit later on and see how they work. So this gives you a nice bird's eye view of how the various elements in a stream work. Oh, great question. The question is, what is the difference between an array and a stream? So an array or a list is an example of some sort of collection, using that word loosely here. And we're going to talk shortly about the difference between collections and streams. But an array or a list or a map, for that matter, or whatever, that's represented in a different way than a stream. And in particular, you can't apply the various filter operations on collections or arrays, but you can apply them on streams. So the best way to think about an array or a list or collection is to think about it as something that holds the data in a somewhat static way. So you have a collection of things, and you can apply good old object-oriented operations on that. You can, for example, you can find out the length of an array. If you convert an array into a list, you can do things like remove elements from it and so on and so forth. But a stream is more dynamic in that the information is flowing through it, and you can apply all these different types of transformers and filters to the stream, which is something you can't do with a list or an array or a tree directly. So we'll talk a bit more about the difference between collections and streams. Something to keep in mind, of course, is that you can take a collection and convert it into a stream, and likewise, you can take a stream and convert it back into a collection. So we'll see a lot of that being done here very shortly. Yeah, that's a good question. So that's the end of visualizing Java streams in action. I will point one thing out, which we'll talk about later. The description here was really more just to get the visualization juices flowing in your head. The actual way that streams behave under the hood is slightly different from the way I described it here. And we'll get to that here shortly when we start talking about stream internals. But that comes a bit later.